Today, as drought intensifies in many parts of the world, the medieval approach feels surprisingly modern. Gravity-fed systems require minimal energy, making them resilient when power grids fail. Rainwater harvesting echoes the old cisterns hidden beneath medieval courtyards. Urban planners now revisit decentralized water storage, inspired by layered reservoirs once used in fortified cities. The idea is simple. Store locally, distribute gradually, protect the source. In sustainable design, buried pipelines reduce heat exposure just as underground channels once minimized evaporation. Even the concept of redundancy, multiple supply points feeding a single settlement, mirrors medieval strategies against siege or sabotage. We often chase complex technological solutions. Yet these ancient systems remind us that the landscape itself can become infrastructure. By respecting slope, terrain, and natural flow, communities reduce dependence on mechanical force. In disaster planning and off-grid living, gravity remains the most reliable pump ever discovered. The past quietly teaches that resilience begins with understanding the earth beneath our feet. In lands where the sun scorched the earth and rivers vanished into dust, entire medieval cities somehow bloomed with fountains, gardens, and flowing baths. How did water rise against gravity and cross miles of barren terrain without modern pumps or electricity? That is the mystery. Imagine standing beneath the towering arches of the Aqueduct of Segovia, stone blocks stacked with such precision that not even mortar binds them. Yet water once glided across its summit as if guided by invisible hands. These were not merely remnants of ancient Rome. Medieval engineers studied, repaired, and reinvented these systems, turning forgotten ruins into lifelines. In dry regions of Iberia and the Middle East, water was power, survival, and political leverage. We often picture the medieval world as technologically stagnant, but aqueducts tell a different story. They reveal quiet brilliance, patient calculation, and a deep understanding of landscape. These structures did not just carry water. They carried hope into unforgiving lands, transforming dust into harvests and fortresses into thriving communities. When the Roman Empire fractured, many grand water systems fell into decay. Yet in cities like Toledo and Constantinople, the knowledge never fully disappeared. Medieval rulers recognized that controlling water meant controlling destiny. In Islamic Spain, engineers expanded irrigation networks inherited from Rome, blending them with advanced hydraulic knowledge from North Africa and Persia. The great Valens Aqueduct continued supplying water centuries after its construction, maintained and adapted by successive empires. Meanwhile, monastic communities across Europe built smaller gravity-fed channels to sustain agriculture in rocky highlands. Water systems became symbols of authority. A city with flowing fountains signalled stability and divine favour. Step by step, aqueduct restoration became a political act. Rulers invested in reservoirs, underground cisterns, and distribution basins. Trade flourished where water flowed reliably. Crops diversified. Populations expanded. These projects were expensive and labour-intensive, yet they paid dividends for generations. In dry and unforgiving lands, medieval aqueducts were not luxuries. They were strategic lifelines, anchoring civilization itself. If you're enjoying the content, hit that subscribe button and stay tuned. So, how did these aqueducts actually work without pumps? The secret was patience and precision. First, surveyors identified a distant spring at a higher elevation than the target city. Even a gentle slope, sometimes just a few centimetres per 100 metres, was enough. Imagine pouring water along a slightly tilted table. It moves, slowly but surely. Engineers mapped the gradient using simple tools like plumb lines and water levels. Next came channel construction. Stone-lined conduits were built to maintain a consistent incline, preventing stagnation. Where valleys interrupted the path, arches lifted the channel high above ground. Where hills blocked the route, tunnels were carved directly through rock. In arid regions, underground sections reduced evaporation and protected against sabotage. Sedimentation tanks were added along the way, allowing debris to settle before water continued onward. Finally, distribution tanks divided the flow into public fountains, baths, and irrigation canals. The brilliance lay in understanding gravity as a silent engine. No moving parts meant fewer failures. With careful maintenance, these systems ran for centuries, powered only by elevation and ingenuity. Medieval aqueducts were more than stone arches against the horizon. They were arteries of survival carved into unforgiving terrain. Each channel represented foresight, cooperation, and a profound respect for natural forces. In cities revived by flowing fountains, life returned where drought once ruled. Imagine the first trickle of water entering a parched settlement after months of construction. The sound alone would have felt miraculous. Yet it was not magic. It was mathematics, patience, and collective will. Over centuries, some of these systems were abandoned as technology shifted toward pumps and pipelines. But their endurance still speaks. Many continue to stand, silent witnesses to human determination. In an era facing climate uncertainty and resource scarcity, their lessons resonate more strongly than ever. Work with gravity, not against it. Design for centuries, not seasons. Protect the source as fiercely as the city it serves. The next time you see ancient arches stretching across a valley, remember that they once carried more than water. They carried the promise of life itself. And perhaps by studying their wisdom, we can build a future just as enduring. If you're enjoying the content, hit that subscribe button and stay tuned.